Hi guys, this is Miss Scott, and we are going to cover the last section in Chapter 6 today. So before we get started with that, here's your joke. What did one cell say to his sister cell when she stepped on his toe? My toe, sis! Yup. All right. So here we go. We're going to kind of keep this lesson short and sweet. We're going to look at 4 theorems and 1 example for each theorem. So we're going to set up some proportions. So your essential question is, what proportion can you write if a line is parallel to a side of a triangle? And then if a ray bisects an angle in a triangle. All right, so go ahead and pause and jot that down. All right, so now we are going to look at some theorems that allow us to set up proportions. And I'll be honest with you guys, you've probably seen examples like these already throughout the chapter. All right, so theorem 6.4 is the triangle proportionality theorem, and that tells us if a line is parallel to one side of a triangle and it intersects the other two sides, then it divides the two sides proportionally. And from that fact, we could set up a proportion to solve. All right, so let's look at what this looks like in a picture. So say I have this triangle here, and then this line right here cuts through it, and these two lines are parallel. So if I call this part here A, and this length here B, and on the right-hand side, this is C and this is D, well, it turns out that we create this proportion. A over B equals C over D. All right, so let's go ahead and use that down below in an example. We're going to use this idea to find the length of segment AB. Let's call that X. So I just look at the left side of the triangle, 18 over X is equal to the right side of the triangle, 24 over 20. And then you guessed it, we're going to cross multiply. So we get 24x equals 18 times 20 is 360. And if we divide by 24, we'll get x by itself. And it turns out that 360 divided by 24 is 15. So that means the segment AB is 15 units long. All right, pretty straightforward. Let's look at another theorem. Very similar theorem here, but this one doesn't have to, it's kind of the opposite of what we just looked at. It's the converse of the triangle proportionality theorem. So this says if a line divides two sides of a triangle proportionally, so now we know all of the side lengths, then it is parallel to the third side. So in this situation, we still have that same picture. We have A, B, C, and D here. But now we're saying if we know that A over B is equal to C over D, then this line, we'll call this line here, I'll just extend this. If we call this line X, and if we call this line here line Y, then we know X is parallel to Y. So notice there's no arrows on this to start with. We need to know that this is proportional to say that those two horizontal lines are parallel. All right, so let's take a look at an example here. In this one, we have all the side lengths, but we're trying to figure out if this line here, WX, is parallel to YZ. So right now we can't tell because there's no arrows, but let's go ahead and set up a proportion. I'm going to look at 18 over 6. We're going to see if that is equal to 24 over 8. And you can probably see what those would reduce down to. You can see by cross multiplying too, just like we've done. So we're going to see if 6 times 24 is equal to the same thing as 18 times 8. And if you plug those in, you'll end up with 144 equaling 144. So that's true, so we would say yes. Line WX is parallel to YZ by theorem 6.5. All right, so this would be our answer right here. Okay, we're going to go on to something similar to these two theorems, but it just adds an extra layer. So theorem 6.6 doesn't have a special name, but what it tells us is that if three parallel lines intersect two transversals, then they divide the transversals proportionally. So again, we're going to set up a proportion. So just go ahead and draw three parallel lines. So I have this line here, and this line here. Okay, so those are my three parallel lines. If they are parallel, I better put some arrows on them to show that. All right, so now I know for sure they're parallel. And then we're gonna intersect those lines, intersect those lines with two other lines. And the two transversals don't have to be parallel to each other. All right, so if I call this portion here A, and this portion here B, and over here I'm going to call this C and D, what we can say here is that A over B equals C over D. The other option is to set up the top part. So there's a second option here. You could do A over C equals B over D. So you can either do this over this equals this over this, or we can do this over this equals this over this. All right, and both will still cross multiply to give you the same thing. So that's why that works. It's actually using that interchange property. Notice we can just switch those and it's the same proportion. All right. So let's see if we can use this in the example below to find F, G, and D, E. So let's just call F, G, X. And then we'll call D, E, this bottom portion here, we'll call that Y, just to make solving a little bit easier for us. Let's find X first. So we can find X by setting up this 6 over X in one ratio is equal to 4 over 6. All right, so let's cross multiply here. So we have X times 4 gives us 4X, and 6 times 6 gives us 36. So if we divide by 4, we'll end up with X is 9. All right, so that means the length from F to G is 9. Okay, now let's find Y. This is going to be a little bit, not really using this theorem, but we can use similar triangles here. So if we look at this entire length here, that's going to go with Y on the bottom. So this entire length, if we add 4 and 6 and 4, we get 14. So I'm going to set up 14 over Y. And then I'm going to grab a highlighter here and we'll make it blue. Let's look at this little triangle on the top here. Notice that Y is the base of the big triangle and 5 is the base of this little triangle. So I'm going to put those both in the bottom. And then 14 is that length along the right-hand side. And then here, 4 is the length along the right-hand side of the little triangle. So now we can cross multiply. We got 4y is equal to 14 times 5. That is going to give us 70. And if we divide both sides by 4, we end up with y equals 17.5. So that means DE is 17.5. All right. Now, the last theorem we're going to look at, I think, is kind of the trickiest here. So This one deals with angle bisectors. So if you take a look at theorem 6.7, it tells us that if a ray bisects an angle of a triangle, then it divides the opposite side into segments whose lengths are proportional. So once again, we are going to set up some proportions to solve this. Let's draw a picture though that helps us to visualize this. So just draw a triangle. And now we're going to cut this angle over here on the left with an angle bisector. Okay, so that this angle here is congruent to this angle here. And if we call this side A and this segment here B, and this side C and this segment here D, it turns out that this side over this side is equal to this side over this side. So A over B equals C over D. All right, so now let's look at that in an example. All right, now what we have to do first is figure out if this really is an angle bisector right here, because we don't know right off the bat. So we can find this angle because 106 makes a linear pair with that angle. So if we take 180 minus 106, that turns out to be 74 degrees right there. All right, and then now we know these two angles. We know that this is 81, and we know that this angle is 74. So we can find that angle by doing 180 minus 81 minus 74, and that turns out to give us 25 degrees. So if this is 25 degrees, that means this angle here is congruent to this angle here. So yes, that is an angle bisector, and we can use theorem 6.7. All right, now the tricky part I think is kind of setting this up. You always set up on one side of the triangle. So in this case, 7 and 3 are on the right side, or sorry, the left side of that angle bisector. And then X and 4 are on the right side. So I'm going to do the longer piece over the shorter piece equals the longer piece over the shorter piece. So now let's cross multiply. We get 3x equals 7 times 4, which is 28. And if we divide by 3, we'll get x by itself. And 28 divided by 3 turns out to be 9.34 if we round that. All right. Well, thank you guys for watching. If you have any questions, come find me. I'll help you out. We'll figure it out together. But we'll see you guys again next time. Take care.